Take a look at this painting. Would you believe me if I said that there was a hidden message within this picture? In 2011, scientist Albert Rito Sanchez and his team uncovered a hidden signature that lied beneath the paint and varnish of this famous painting, Sacrifice to Vesta. They were able to achieve this by using a powerful imaging tool known as terahertz imaging. But what is terahertz imaging, and what potential applications does it have for the future of medical imaging? Well, just as other forms of radiation that we are familiar with, like X-rays, gamma rays, or UV rays, terahertz radiation, or T-rays, is the radiation described roughly between 100 GHz and 10 terahertz of the electromagnetic spectrum. T-rays have always been in existence for as long as we know. The reason we probably haven't heard much about its application is because it was extremely difficult to detect and produce T-rays. So, for a long time, this region on the electromagnetic spectrum has been known as the terahertz gap. That was until about the 1980s, when recent technology opened the way for better detection and production of T-rays. Now that this spectrum has been made available, scientists are now exploring the possibilities of applying this form of radiation in medical practice. Can this new method of medical imaging match those capabilities shown of X-ray imaging or MRI? Is T-ray imaging on the verge of revolutionizing the way we treat and detect diseases?
Now I'll be describing terahertz radiation importance and the pros and cons. The main feature that makes terahertz radiation more attractive for medical uses is its safety. Unlike other electromagnetic radiations, such as X-rays, at higher frequencies the energy produced by terahertz radiation is too weak to disrupt electrons from the atoms, and therefore does not ionize materials. Consequently, living tissues will not be damaged from the low energy levels produced by the radiation. Now, I'll be talking about the pros. To start with, ex vivo spectroscopy. Imaging in the terahertz frequency range can be used to render real-time imaging during surgical operations to avoid cutting off a lot of healthy tissue and exclude leaving any part of carcinoma in a patient's body. This in turn considerably reduces the likelihood of a need of a repeat invasive operative intervention in the future. Next, in vivo spectroscopy. Many researchers confirm that in a certain frequency range, most tumors have lower absorption than normal tissue. The obvious conclusion here is that terahertz imaging can distinguish tumors from normal tissue. Such biopsies enhanced by T-ray spectroscopy save a lot of time and effort by reducing the number of repeat surgical procedures in breast and skin cancer treatment cases. After that, dental care. Many researchers agree that when THZ pulses pass through the tooth, it allows making highly important measurements of it. For instance, enamel thickness and pulp cavity regions, which can be identified via absorption of terahertz pulses in the tooth, and this will allow the dentist to choose the right type of treatment to treat the case. Now is going to be the cons. Researchers from the Korean and Advanced Institute of Science and Technology conducted an experiment on a genetically engineered mouse that was exposed to high terahertz radiation for about 30 minutes, and the skin of the mouse was monitored with a microscope. And the result was that the team found that the number of the infected cells increased more than times after 6 hours of exposure.
As you have seen, there are many terahertz imaging modalities that have great potential for the future of preventative healthcare. The fact that terahertz radiation, unlike X-rays or UV rays, is harmless to humans provides an enormous opportunities for its application in medicine. it is clear that applications could benefit from a frequency that is harmless and has the penetrating ability to make the invisible visible. Further research in order to improve the terahertz imaging performance and to make it less costly and more portable will lead to advances in many areas of medical diagnostics in the near future.